Hello, everyone, and welcome at the second meeting of Seismic. As you already know, I am Marios Poulas. I will be together with you for the networks, the first part of networks, which will be the today's module. Let me get straight away to the today's lecture. As said earlier, the today's lecture is about networks, and I will show you a picture first of all, so you get the concept and what the today's um, lecture is about, and what's the use of the networks in Matlab. Okay, so hopefully you can see an image now which says plant residues. Am I correct on that? Can people? Great, thank you. So this is a biological network. This is an image that you can find on your textbook, the seismic textbook. It's basically the soil biota food web. This is a biological, I'm using this as a biological network example, just for you to understand what our aim is today and what the networks are gonna use us, how are we gonna use the networks in Matlab and the Biograph functions and the matrix functions to create the matrices in order to understand the biology behind what you are seeing on your screen right now. So we can see some nodes and some edges there. The nodes are the, let's say, bacteria, fungi, mycorrhizae. These are the nodes of the matrix, and the edges are the arrows that are connecting them with each other. Sometimes an edge can go both ways. So node 1 can go to node 2, and then node 2 can go to node 1 back with the feedback. I'll leave the example here and I'll proceed to the Matlab coding. So this was for you to understand what we are gonna do. Let me stop sharing this image and I'll try to share with you. So this is something I created earlier and we are gonna go through this script today to explain the networks, the nodes, the matrices, etc. And at the end of the lecture, or maybe within the next couple of days, I think, Carol is gonna share this script with you via the Seismic website. At the previous lecture, we kind of got an introduction into Matlab. We showed the different parts of Matlab, the live editor, the folders, the workspace, etc. Today we are gonna work on the live editor. In the previous lecture, I also shared some tips on how to work with Matlab and how to work through the seismic. But for today, let's focus on how to work with Matlab. You can see in lines 4 and 5, the clear and the CLC functions. These are two functions that I always use when I start working on a new, not just a new project, but let's say in a new script. I always use the clear and the CLC in order to clear all the previous information that was created and start from a new, on a new workspace, a clear workspace. So if I run the clear function, as you can see in the workspace, it deleted all the previous variables that were created. And the CLC function is gonna clear my command window at the bottom. So now I'm starting from the beginning, from scratch. Going to nodes and matrices. As said earlier, the nodes are the various nodes of a biograph of the previous screen, of the previous image that I showed you. which can be the fungi, etc. Those were the bacteria. Those were the examples earlier. And the matrices, you are all aware about the matrices. A matrix has a number of nodes. In order to create a matrix, you need to know the number of nodes. For this example, I'm using the I'm aiming to create a matrix with 5 nodes. This means that we are going to have a 5 by 5 matrix. In order to create the matrix, we are always using the, let's say we are going to create a random matrix. I mean, with random numbers, as showed you in the previous lecture. The function rand, rand, and specifying the number of nodes is going to create us a matrix with random numbers. Let's try this. So at the moment, I'm just gonna run the highlighted code, nothing else. Sorry, yeah, I've got the n there. It was supposed to be 5 because I didn't run the n earlier. So now it's gonna create me a matrix, a 5 by 5 matrix, as you can see at the command window below, with random numbers. If I run it again, it will create another matrix with other random numbers. As many times as I run it, you will see that it creates different matrices each time because it's random. Let me get this back to n. In order to have integers, we will have to use the rand_i function. But before getting there, in order to, if we want to create another matrix or whatever with a different number of nodes, in order not to have to run through the whole script each time and change the number of nodes one by one, we used to set it into a variable and set the number of nodes there. So if I set the number of nodes, let's say n equals to 5, and then I will be using n, the variable n, in the whole script below. This will save me time if I decide at some point that, okay, I now need a 3 by 3 matrix, or I now need a 10 by 10 matrix. I will not have to run through the whole script and change them one by one. I will just change the value of the variable n at the beginning and rerun the whole script. This is what we can do. It's very straightforward. For now, let me have it as 5. I will now run n equals 5. By the way, when running a piece of code, you can see at the command window that you can see the function that I ran or the coding that I gave, and then you can see below the answer. So the answer is n equals 5. It's like I'm typing there and it will give me the answer below equals 5. If I want to suppress the answer and not get it each time because it's gonna mess up my whole the command window, let's say, with answers, I can just press the semicolon at the end of, I can just add the semicolon at the end of each line. And now if I run this script, it's gonna just give me the script that I ran, the code that I ran, without the answer below. For the purposes of this lecture, and probably for the future lectures, I'm gonna keep them without the semicolon, so you can see the answer straight away and we can discuss them. So for now, we've set the number of nodes to 5. and we are about to create a matrix with random numbers with this number of nodes, number of nodes. For the purpose of this lecture, I've got the code in black, the one that we will be using, but I've got some comments. As said earlier in the previous lecture, we can comment on within the script by adding the percentage sign at the on the front of each line. So it makes it green, and this means that it's a comment, and when running the script it will not pay attention into those lines. If I want to run this script, I just delete the percentage sign, and this will create it another line of code that that Matlab is gonna take into consideration when running the script. Or if I just select the whole line without the percentage and run it, it will run this this piece of code. This is what I'm doing now, and as you can see below, I created the random matrix with integers from 0 to 1. Sorry, not integers, from 0 to 1. As said earlier, if we want it to be just integers, we have to use the rand I function. So let me try it here for you to understand what I mean and before proceeding to the rest. So I now set my matrix with random numbers. And at the end of, before proceeding, at the end of each section, of each script section here, I added some links here, where by clicking them, it takes you straight away to the MathWorks website, where you can view the information about the, let me show you what I mean. I'm not sure what you can see right now. Can you see the Matlab, the MathWorks website with Rand? Great, thank you. So this is what I mean. When you click on those links that you will find on the script that we will share at the end of the lecture, it will take you to the variable, to the functions that we are using today, that we will be using today. So you can read through, and please use the MathWorks as much as possible. This is how you are gonna learn Matlab. You are gonna learn the basics and some more advanced functions through Seismic, but then it's your work. You will have to work in order to learn more Matlab. And also use Google, as said in the previous lecture, use Google as much as possible for you to learn Matlab. I'm stop sharing this, and I'll get back to what I was sharing earlier, the Matlab. Great, so you are now in the Matlab window, right? Great, thank you. So if we want to create a matrix with integers, we use the rand I. You can, it's a uniformly distributed pseudo random integers that the rand I function creates. For this, we will have to specify, first of all, the numbers between which, the range of numbers between which we need the matrix to be created. Here, for example, I'm specifying 0 to 1 with n nodes. That means it will create a matrix with n, which is 5 by 5 matrix with numbers between 1 and 0. 0 and 1, but they are all integers. So here we've got only ones and zeros, as you can see. I could have used the number 5, which would have given me a matrix with numbers, a random matrix with random numbers between 0 and 5. If I don't want the matrix to be a 5 by 5, if I want it to be a 4 by 6, as I mentioned below, or a 10 by 5, or a 100 by 1, or whatever, I just specify the numbers after the comma. So here I will get a matrix with only zeros and ones, and it will be a 4 by 6 matrix. If I just run this code, you can see we've got 4 rows and 6 columns. It's a 4 by 6 matrix. For the purpose of this lecture, let me get back to the 5 by 5 random matrix. And yeah, here I always add a few comments so you can read and understand what we are doing, and what some comments on the previous coding. So here I just explained the rand, what the rand function is. I did not explain the rand I, but as said earlier, you can just click here and MathWorks is gonna explain it for you. Proceeding, if we then want to access specific values within this matrix, we just have to specify them here. So after the name of the matrix, and I named it my matrix, I remind you that you cannot have a 2 or 3 or whatever number of words in the variable number. You can have it, but you will always have to you cannot use spaces in between names of variables. That's why here I'm using the underscore in order to connect the two words. So the matrix named my matrix, and I want to access the first element, the element in the first row and the first column. By running this script, this piece of code, it will give you, you can see the answer is 0, which means that the first row and the first column, the value in the first row and the first column is 0. If I want to access the first row, the first column, and the fourth row, let's say, which is number 1, here I've got it, I'm accessing the first row and the fourth column. It will be number 0. So let us see this first. As you can see, here is 0 and is that one. And now I'm gonna change it. Let me copy it below. Let's access the element on the fourth row and the first column, which we expect it to be number 1. Running this piece of code, it's number 1. So it will return whatever element within the matrix you select. And then we've got the function size, which can give you the size of the array size of the matrix. And I'm using it here to see that I've got a 5 by 5 matrix. If I had the 4 by 6, I would have get the 4 by 6 matrix. And size is a very important function. You are gonna use it a lot further down the line because you will need to access either the number of columns or the number of rows in order to proceed to further coding. So you will be using that one. If I want to access only one of the two, I will have to press comma 1. I will have to add this in brackets, and let's say a equals whatever. This will return me, This will give me the one. So this is how you will access the number of rows or the number of columns, depending on what you need for further use. Proceeding to the creation of networks, and then I'll give you 5 minutes for a short exercise. Here what I'm doing is to specify the number of nodes. It's I'm specifying 3 nodes, which means if I create a network with this number of nodes, it's going to create me a 3 by 3 matrix. Here I'm using function zeros. This means it will create a matrix with all the values of it zeros. So by running these 2 lines of code, it's going to give me a 3 by 3 matrix with all values being 0 within it. And this is what I get here. You can see it in the command window. If I want to access a piece, a part of this matrix and change it, as said earlier, we just have to specify which position we need to access. Here I'm accessing first row and second column, which is that one here. And I'm gonna change it into 1. Let us run this part. And as you can see, the first row and second column is now set into 1. As a second example, we are changing row number 2 and column number 1. So I expect this one to change into 1, as you can see here. Let me get a step back. What does this actually mean now is that element 1 is connected to element 2. And here it means that element 2 is connected to element 1. So node 1 has an edge that connects it, let's say an arrow. By saying edge, I mean an arrow, which connects it to node 2. Then node 2 goes back to node 1, connected by an arrow. This is with a feedback, let's say. It's a reciprocal relationship. And then if you need, say, to 2 different nodes at the same time, you will just have to use not the round parentheses, but the square parentheses to create an array. That means that node 3 goes into both directions. It's connected to node 1 and node 2. Let us run this just to see how it will look like in terms of the matrix, and we are going to visualize it towards the end of the lecture. So by running this, as you can see, we've got line 3, row 3, which is here, and we can see column number 1 and column number 2, and they are now set into 1. Clear? It's clear, I get. And I've prepared an exercise for you to get through. I'll leave you 5 minutes to try and do this exercise, and let me know if you've got any questions up to this. So now you will have to set up a 5 by 5 matrix, which will have all its values set to 1. Earlier, we used the function zeros to create a matrix with all zeros. Now you will have to set them all in 1, all to value 1, and then amend the elements 2, 4, 5, 6, 7, 15, and 23 to 0. If you have any questions, you can just open your microphone and ask me straight away.
Hi, Marius.
Hi.
Hi. So do I start with a matrix of zeros and then change them all to 1 and then do the others? Or is there an easier way to do a matrix of 1s? There must be. Yeah.
Indeed, there's an easier way. and I wanted you to get there.
Okay, well, yeah, I'm not there.
Look, Zora, we are gonna go through this step by step together, because this was an exercise. I wanted you to run through this exercise, not just to solve what the exercise is asking you, but to find a way to solve any kind of question that you've got your own way, by your own.
I'm sure I've done this before, but but maybe it was the matrix of zeros that.
Okay.
Yeah.
How would you? It's great that you thought that there's an easier way.
Yeah.
Okay, it's great. So you did half of the job there. How would you finish it? What would you do now that you thought that there's an easier way rather than?
I'm gonna go into the help and see if there's a way to adjust the matrix to not just make a random matrix, or to make it a matrix of zeros, to if I can set the matrix to have the value that I need.
Yeah, great. Thanks for bringing this up, though, Zora. And let me show you what I would have done in your position. So let me show you one by one. So the first solution, which is the complex solution, as you said, is to create a network with all zeros, and then start changing them one by one. So row 1, column 1, set to 1. Then I'm not changing number 2, because this is what the exercise was saying, to set number 2 into 0. So this is why I'm not changing this. And I'm just going to row 3. 3, first column, setting it to 1. This is what I did here. Then I'll go to 4, 5, 6, 7, 8, 9, 10. As you can understand, each element here, you can access each element using 2 ways. One is by giving by giving both the row and the column,
like a grid reference,
or 3,1, etc., or just by accessing the number of element. And by saying the number of element, I mean here we've got a 5 by 5, 25 elements, starting from the top left row, going downwards. So this is 1, 2, 3, 4, 5, and then it's again row 1, second column, 6, 7, 8, 9, 10, 15, 20, and here is number 25. Okay, so you will have to change 25 nodes one by one. This is the painful way. What you could have also done is to create the network with all zeros, a 5 by 5 with all zeros, and then, as said earlier, you okay, now is the first time I'm saying this. Instead of accessing 1.1 or 3,1, etc., you can use the colon, and this means it will access the full, the colon in the row part. So you can see here are the rows, and the second one is the columns. Okay, that means it's the full row or the whole column. Okay, what I'm doing here is to set set my network, set this matrix, all rows and all columns to be equals to 1. Okay, so if I run this part of code, you can see that my network is set to 1. Okay, this is a much more straightforward way of doing it. And then you will have to access the nodes that the exercise was mentioning, 2, 4, 5, 6, 7, etc. You will have to access them either one by one and set them back to 0, which is what the exercise was asking you. Or there's an even easier way, and this is what I am, this is the best option for me, at least, and I'm gonna show you. First of all, I'm starting by setting the number of nodes into a different variable. as told you at the beginning. So I'm not putting 5 here because I might need to change it at the end. Later in time. So I'm just first of all creating a variable number of nodes new for the new network, the new matrix equal to 5. And then I'm using a different, I'm using a different function which is called ones. How did I manage to get this function? I didn't know that earlier. So what I had to do, let me stop sharing this and I will again.
I typed in 1. I should have typed in ones.
Yeah,
it didn't work with 1.
Okay, very clever to think of this, but you didn't know the exact answer,
no,
and you had to find it. You don't have to guess, you have to look for it and find it. So now you can see a browser with a lot of tabs open for MathWorks, right? Great. What I did here is to go into Google, which is the very straightforward way of doing it. And I just typed how to create a matrix with all ones in Matlab, right? This is what I did. And I just click on the first option here, on the first result here, and it takes me here. It gives me that the function I need is ones, and it creates an array of all ones. That's how I found it. That's how I find which function to use.
Okay, I'll use Google next time before asking you.
Yeah.
Okay, yeah. Thank you.
This is exactly what I wanted. It's great that you brought it up, and thank you, Zora. This is exactly what I wanted to happen. I wanted to explain and show you. It's experiential learning, right? And show you how to use it. So here, what we did is to use my network to create a matrix named my network new, bearing all values with the value 1, and the number of nodes equals to 5. So it's a 5 by 5 matrix with all ones, as you can see here. And then instead of changing each node 1 by 1 into 0 as we did earlier, we just create an array. As told you earlier, we added in square brackets, as you can see, and we create this array here, 2, 4, 5, 6, 7, 15, 23, which is what the exercise was asking us earlier. So these elements of the 5 by 5 matrix are now going to be turned into 0 when I run this this line of code. And this is what happened here. Right? So this is the answer to the exercise. It's not for you to get the answer, it's for you to get the way of getting to the answer, right? So now next time you know what to do. And below, yeah, I show you, I add the links for zeros and ones function, so you can have a look yourself later on. As said earlier, is what I showed you earlier. If we want to see some matrix features, for now we need, let's say, to find the number of nodes and the edges. Starting with the number of nodes, we will have to count the number of nodes. Okay, this is not a great question because you just run the number of nodes. It's a variable. You will have it here, and the number of nodes now is 3. As you can see here at the workspace. If I run this part of code, the answer is there, is 3, it's very straightforward. But if you wanted, if you didn't know that, or whether for in other cases, you will not have a variable bearing this, and you will need to assign this to a new variable. What you will have to use is the size, as showed you earlier. The name of the matrix, comma 1, will give you the number of nodes. Okay. Proceeding, and now what I did is to assign the number of nodes into the variable named number. This is what we did now. Proceeding to the edges, as said earlier, the edges are the arrows that are linking the nodes with each other. If we need to know the number of edges that are present in the network, what we have to do is to use the find function. As you can see here, the find function find indices and values of non-zero elements. If you remember from what we saw here at our network, we've got a network where with all zeros and ones. Sorry, we've got a matrix with all zeros and ones. Where we've got zero, that means that there is no connection between those nodes. When there's one, that means there is a connection. That means there is an edge connecting the two nodes. So for here, element 3 is going to element 1. Element 3, because it's row 3, is going to element 1 because it's column 1. Here, element 4 is going to element 3, as you can understand. So there is an arrow from node 4 to node 3. Is this clear? It will become clearer when we get to the biograph function, and there is not much time, so let me proceed there. Having the edges, I'm assigning the number of edges here into a variable named edges. So here we found all the edges that are present within this network. So we've got four edges, four arrows connecting the nodes in between them. If we need to get the number of edges, we will have to get the length of this array named edges, which bears all the edges of the matrix. So what number of edges do you expect this matrix to have? As you can see from the array here, there are 4 edges. So the length is going to be 4. So the number of edges of the network is 4, as you can see here. Okay, and we can here we use functions to get the to find the indices of the matrix and then count them using the length and find the number of edges. And now I'm proceeding to the biograph function in order to visualize the matrix, and it's for you to connect it to the first image that I showed you at the start of this lecture. Here I copied and pasted a network which I created here. If you don't have it straight away, if you don't have it given and you want to create it, this is the code that you need to run. By the way, by pressing the command and T, letter T in your keyboard is a shortcut which gets the code out of the comments. So now it's a piece of code, this. If you want to select a part of the coding and get it back to comments, you want to comment it out, which means when running the script, the Matlab is not going to pay attention to this part. You just press command again, and I don't know which part is in your keyboard, but it's the slash, the backward slash. Okay. And now I commented it out again. Let me have it out of code, out of comment for a second so we can run it. As you can see here, we are creating a value with the number of code, a variable with the number of code of nodes is going to be 5. Then create a matrix 5 by 5 by running this. And then we are gonna set this array by using this array. As you can see, you cannot see it here actually. We are gonna set these elements of the matrix equal to 1. And you can see the network, which is exactly the same as if I had run this. You can see it here as if I had run it from the beginning. It's exactly the same. Okay, I'll have it commented there and leave it for you so you can actually let me this. So it's for you to find it later on and work with it and play around so you can understand more. If we want to show the size of the matrix, as said earlier, we can just run the code size, the function size, and then specify in round parentheses the name of the variable that we need. We've got a 5 by 5 matrix, and if we want to get the number of nodes, we just specify the first one, which is the nodes here, and we can see that we've got 5 nodes for this matrix. If we want to show the number of the edges, as said earlier, here what I do is firstly to create a variable named edges to find those edges for it. But what we do is to specify all the elements within this network that are equal to 1. I wrote this somewhere as a comment, I think, but I cannot find it. Maybe it's further down. Anyway, so equal is a logical function, is the logical equal, and means, let me see, because I remember I had it somewhere and you need to. Strange. Ah, I had it here. I should have explained it here. Yeah. What we do here is to find the edges within this network named my network, within this matrix named my network, that are all equal to 1. And as saying here, equal is the logical equal, which means we are getting all the values that are equal to 1 within this matrix. If I wanted to get all the values that are equal to 0, I could have placed number 0 here and run it, or I could have used the logical less than 1, and obviously the less than 1 is 0 because I only have 0 and 1s here. Okay. We'll discuss the logical equals in the logical less or whatever in later lectures. So what we did here is to find the number of edges. We've got all these edges are equal to 1, and they are 9. So I've got 9 edges that are equal to 1. That means I've got 9 arrows connecting the 5 nodes with each other. And let us visualize this to understand better what's going on. To visualize a network, we use the function Biograph. By start typing Biograph, I was expecting the C matrix to appear. What will happen here is that it will create a Biograph object, and I've got the link below, for the matrix named my network. Okay, by running this, here I copied and pasted to mention the the semicolon, but I mentioned it earlier. In order not to suppress it, we just use the below line. As you can see here, it says that biograph object was created. It's named BG, and you can see it here at the workspace that we've got a biograph object. It even has a different icon, and it says that the biograph object has 5 nodes and 9 edges, as found, as said earlier. If you suppress it anyway, it will just give you the biograph object without mentioning that it's 5 by 9. However, it only creates the biograph, but it doesn't show it to you. In order to view this biograph, we need to use the view function, and then in the round brackets, we will have to add the name of the biograph object. The name of the biograph object is BG. I am using it here, and I'm naming this view, the one that we are gonna see now, as BG view. Okay, so by running this piece of code, it will take some time and create a biograph. Now you will be able to see the biograph that was created. Okay, as you can see, we've got 5 nodes, 1, 2, 3, 1, 2, 3, 4, 5 nodes, 1, 2, 3 edges, 3 arrows, 4, 5, 6, 7, 8, 9. In some cases, as said earlier, you can see that node 1 goes to node 3 and node 3 goes back to node 1. In some other cases, it's just node 2 going to node 4. It doesn't go back. Okay, it's what we said earlier. So where there was a number 1 in the matrix, that means there is an edge. That means there is an arrow connecting the 2 nodes. In order to explain how we can amend the elements of the biograph view, here is how to modify some features of the graph. We have time, we've got 5 minutes. I'll be very quick on this. We use the function set. There are 2 sets, it's to set the graphics object properties. The function is the same. It's set and set. You don't define different functions. It's set. But if you use it for a biograph, it will act as you can read here. If you use it for other graphic object, it will act as you read it here. So for here, we are using set function. In the round parentheses, we are specifying the name of the biograph view of this image that I showed you. And then we press in order to access a specific label of the biograph. And by saying label, I mean either the nodes, the edges, these kind of things. We have to access them by using the dot. So biograph view name dot nodes or dot edges or whatever, and then we add the property that we need to amend. Here we are amending the font size, and we want it to be 23. So we are making it bigger, I think. Yeah, great. Now you can see it on the same screen, right? I don't have to, great. So what we did now is to change the font size to 23, made it a bit bigger. Hopefully it will show the changes that we are going to do here so you can see it. On the next line, what I'm doing is to modify a specific, it's lost here, right? Or maybe we can find it. What I will try to do here is to amend a specific node, not all of them, but node 3. That's why I specify next to the nodes. So here what we are getting is to, within the biograph view that we are viewing, the nodes, and from those nodes, node 3, we are going to amend the color, and we are going to set it into green. As mentioned in here, we, for the color, we are specifying into red, green, blue. So here I've got red 0 and blue 0 and green into 1. So it's full green. It's going to be a color green. Hopefully it will show up on the right hand side so you can see it, and I don't have to share another screen. No, it didn't happen here. Probably I will have to be sharing the other object, and it's gonna be, but maybe you can view this later on when you work on your own thing. And for the last one that I've got here, we are trying to amend, to modify the edges. We are changing the line color, which means is here we've got number 1 in the blue thing, from the lines, the arrows from black that are at the moment are gonna turn into blue. I'm gonna run it. It's not that you are gonna see it at the moment. And I'll aim to run the codes as said earlier, so you can see the font size changing. Now I run the first line that I had earlier. I'm running the color of node number 3 to change it into green. And I'm also running the third line, which I'm gonna turn the edges, the arrows, to blue. And this is what I did here. What I wanted to show you, and this is gonna be very straightforward, 5 minutes, and then I'm gonna finish the lecture, is that you can interact with the biograph viewer and change the biograph view that you've got here as you would like. By hovering your cursor above the nodes or above the edges, you can see that you can select them. I'm selecting node 1. I just clicked on node 1, and you can see that the square, the line behind on it turned red. That means that I selected this node now. And by either double clicking on it or by clicking right click and going to node properties, can you see Matlab, biograph viewer, and now the node properties?
Yes.
Great. So by clicking right click and node properties, this window opens and I can amend whatever I need to amend from the properties. As you can see, these are all the properties that are present in the biograph. Let's say I need to change the color, RGB again. By clicking OK, it will amend the color. So if I close it, you will see that the color changed into the color I set. Getting back to node properties again, I can change the font size from 23 that I said it earlier. We can now set it into 30, for example. We can change the line color on the round of the around this node. We can change the text color. Let's make it blue. And now if we go back and see this, the changes have been done. What you can also do interactively is to click on each node that you need, select it, and then drag it and take it into a new position. The edges change according to the position that you place it. You can select more elements than one. Now I selected node 5 and node 3 by just clicking my arrow at a point and dragging it to select them both. and we can drag them both and rearrange them. You can also click in a white space on the, right click on the white space, and you can say refresh edges or refresh layout. Refresh edges, it will change the edges around to look nicer. If you select refresh layout, it will set the layout into the one that was at the beginning. Let's try refresh edges. So the nodes stay pretty much at the same position, but the edges change in order to be nicer, to be viewed in a nicer way. If you select refresh layout, it will take it back to the first position that you had it at the beginning. And what else you can do is to right click on an edge and select edge properties. And now you can amend the properties of the edge. So let's say we need to amend the color from blue to pink and change the line width from maybe in a network you need to emphasize a specific edge. We can make it 5 instead of 0.5, and this will be, sorry, line width 5, and now its width is much more thicker than the others. This is how you emphasize on specific nodes, on specific edges, etc. This is what I wanted to show you for today. You are now probably ready to proceed and finalize the exercises that you've got for this week. And what I want to show you is that edge type, for example, edge type is not a label. That's why we cannot add it, we cannot access it using the dot here. That's why I wrote not okay. It will not work if I run this code, this piece of code. The way I will be able to access it is what I was doing here with line color or color font size. It's a property. That's why we can only access it by the comma and using the apostrophes. I just selected edge type to show you it could have been line color, it could have been color, it could have been font size, or all the other properties that you just saw in the actual biograph. At the end of this code, okay, I've got the set biograph here that you can access, and at the end of this code, I've got the descriptions of the functions with the links that you can find anyway. Gerald is gonna be uploading this piece of code into the website so you can access it. So we've got the biograph here. Let's say we make the amendments or whatever that we did earlier. By going to file, we can have it as a figure now. And I can go to file, save as, and save it as a picture. I select the file that I want to save it, and the format can be either a Matlab figure. So each time you open it, it will open, as you can see it here, a figure within the Matlab. Or you can go save as and save it as a BMP or EPS or JPG or whatever format you want to save it. And just click save. Thanks, Gerald. Thank you, people. And see you in 2 weeks' time.
Bye.
Bye-bye.
Bye. Thank you. Bye.